How did the Vikings build stormproof houses without nails or cement? Their methods will definitely shock you. A North Atlantic storm is not just wind. It is a roaring force of nature capable of tearing off roofs and splitting rocks. In this world, on the edge of inhabited land, the Vikings built their homes. They erected huge halls that stood for centuries without a single iron nail or drop of cement. Their buildings were not just shelters. They were living beings, imbued with the wisdom of generations. These houses breathed, bent in the wind, but never broke. The secret was not in their strength of resistance, but in the ingenious philosophy of flexibility borrowed from their legendary ships. We tend to think of them as warriors, but they were perhaps the greatest carpenters of their era. They read wood as we read a book, knowing how to make it serve without breaking its will. It was an art born of harsh necessity. Watch the video to the end, and you'll learn how just one ingenious type of wood joint, carved with jeweler's precision, allowed these houses to withstand the most violent storms the world has ever seen. What if I told you that everything you believed about Viking houses was wrong? Forget the image of a low, dirty shack where people lived mixed in with livestock in the dark. The reality was much more impressive and complex. These were not huts. They were palaces made of wood. The Longhouse, or Langhus, was the center of the Viking universe. These structures reached incredible sizes, sometimes up to 80 meters in length. This is comparable to the size of a modern apartment building. Inside such a hall, the entire clan could be accommodated. Dozens of people, warriors, servants, and craftsmen. It was not just a dwelling, but a fortress, a warehouse, a workshop, and a place for feasts. The structure was designed to withstand the weight of huge amounts of snow in winter and not succumb to hurricane-force winds. This required engineering thinking that we rarely associate with this era. The central part of the house was a huge open hall. A long hearth burned here, the smoke from which escaped through holes in the roof. This is where life was bustling, decisions were made, and sagas were told. It was the heart of the community, beating to the rhythm of fire and craftsmanship. Contrary to popular belief, part of the house was indeed set aside for livestock during the winter. But this was not a sign of primitiveness, but a brilliant solution. The animals, living under the same roof but in a separate section, gave off a huge amount of heat. This heat helped to heat the living part of the house, saving precious fuel. What image comes to mind when you hear the words Viking house? Did you imagine such a large and complex structure? Share your thoughts in the comments, and don't forget to subscribe to our channel to learn more about the hidden technologies of the past. I will reveal the most closely guarded secret of their durability, and it lies at their very feet. The main enemy of any wooden structure in Scandinavia was not storms, but water. Damp soil, constant rain, and melting snow all caused the wood to rot at its very foundation. The Vikings knew that a house standing directly on the ground was doomed. Their solution was simple and timeless. They used stone, but it was not a cement foundation. It was dry masonry, the art of laying stones on top of each other without any binding mortar. Master builders carefully selected flat boulders to create a solid and level foundation. These stones formed low walls around the entire perimeter of the future house. The main task of this stone anchor was to raise the first, most important wooden beam above the wet ground. This beam, called sillstock or legend, was the soul of the house. It bore the entire load from the walls. Thanks to the stone cushion, it always remained dry. Air could circulate freely under it, carrying away moisture and preventing rot. It was the first line of defense against the cold. The stone foundation prevented the icy wind from blowing under the floorboards. It also served as a barrier against rodents and small pests, preserving the supplies stored inside.
Lift with the lever. Steady.
The precision with which these stones were fitted together is astonishing. There were no gaps between them where water or wind could seep in. This required tremendous patience and an intuitive understanding of geometry. Each stone found its one perfect place. How long do you think it took the team of builders to prepare such a stone foundation for an 80-meter house by hand? But a strong foundation is nothing if the walls cannot stand. In the next chapter, we will see how their shipbuilding skills created something unimaginable on land. What I am about to show you has changed everything we know about ancient architecture. When we think of wooden walls, we imagine either a log cabin made of horizontal logs or modern plank walls. The Vikings took a different path, and it was the sea that inspired them. Their houses were built on the same principle as their drakars. The secret lay in the technology of stavak, or post and beam construction. It is one of the most unique and unconventional techniques in the history of architecture, and it was created to combat the elements.
This brew will warm your bones.
Instead of stacking logs, they placed vertical posts, staves, at key corners and along the walls. The craftsmen carved deep vertical grooves into these massive posts. It was precision work that required a steady hand and a keen eye. Then horizontal boards were inserted into these grooves like rails, one board on top of another. These boards, or tilja, formed the wall. They were not nailed or glued. They sat loosely in the grooves of the posts. This was the genius of the design. Wood is a living material. It breathes, swells with moisture, and shrinks in the heat. In a rigid structure, this leads to gaps or cracks. But in a Viking house, the boards could move freely. When hurricane-force winds hit the house, the wall did not resist until it broke. It breathed. The boards shifted slightly, bent, absorbing the energy of the impact. The wall was flexible, like the hull of a ship on a wave. This flexibility made the structure incredibly stable. The wall could withstand tremendous wind pressure that would simply break a modern frame wall. It did not break because it was designed to move. Like this video if you didn't know that Viking house walls were as flexible as their ships. It was a technology born in storms. Are you ready to learn the truth about what really held up the roof? We just talked about the ingenious exterior walls. But here's a shocking fact. In most longhouses, these walls didn't support the weight of the roof at all. They were just a curtain against the wind.
Wind howls fiercely tonight, little one.
The entire monstrous mass of the roof, covered with tons of turf and snow, was supported by a completely separate internal structure. It was the skeleton of giants, 2 rows of massive posts dug into the ground that ran the entire length of the hall. These posts were carved from the trunks of centuries-old trees. They were the main element of the house. These internal supports were connected at the top by sturdy crossbeams. On top of these beams was laid the longest and thickest beam in the whole house, the ridge beam. It was on this beam, like a spine, that the entire rafter system was supported. This grind-a-big type of construction created a huge, uninterrupted interior space. The outer walls were simply cladding. The inner pillars were the load-bearing frame. This made it possible to build halls of incredible width and length. This solution was not only structural, but also social. The absence of internal load-bearing walls created a single hall. The entire clan, the entire family, lived in one space. This strengthened the sense of community and unity.
That is fine work, Thorkel. Worthy of the chieftain's hall. It will be strong, warrior, as strong as your axe.
The pillars were often not just functional. They were covered with intricate carvings. They depicted gods, heroes, and mythical monsters. They were not just supports, they were the guardians of the house. Columns that held not only the roof, but also the sky of their owner's world. Because the outer walls did not bear any load, they could be made relatively light. Their main task was to protect from the wind, not to support weight. This division of functions, an internal skeleton for weight and an outer shell for protection, was the pinnacle of engineering thought. Thanks to this method, the house could be easily modified. It was possible to remove part of the outer wall, make a new entrance or extension without fear of collapse. The load-bearing frame remained intact. Could you imagine living in one huge hall with no private rooms? But how could these giant logs be joined together without a single nail? In the next chapter, we will reveal the secret of the wooden nail. Imagine the task. You need to connect two massive logs that will support the weight of the roof. You don't have a single iron nail. Iron is too expensive. It is used for swords and axes. Your only tool is wood. The Vikings' solution was the tree nail, a wooden peg. This was not just a stick hammered into a hole. It was a complex and ingenious technology that made joints stronger over time. It was the foundation of both their homes and their ships. The strongest and densest wood was chosen for the nail. Most often it was oak, ash, or juniper. The material for the peg had to be harder than the main logs of the structure. First, the craftsman drilled a through hole in the logs to be joined. A special drill with a long handle was used for this. The hole had to be perfectly smooth. The dowel itself was cut with incredible precision. It was not just round. Often it was given an octagonal or square shape. This was done so that when hammered in, the sharp edges would cut into the wood, creating maximum adhesion. The most important secret was in the preparation. The peg was dried to the limit. It was kept by the fire or in the sun until all the moisture had gone out of it. It became as hard as bone and slightly reduced in size. Then this over-dried peg was hammered forcefully into the drilled hole. It passed through both logs, fastening them tightly together. At both ends, the peg was wedged with small wooden splinters for additional fixation. And now the magic began. The surrounding wood and air were more humid. The peg, being inside the structure, began to slowly absorb this moisture. It swelled. As it swelled, it expanded inside the hole with incredible force. It filled every tiny crack, every pore. The joint became completely monolithic, much stronger than if it had been knocked together with an iron nail. An iron nail rusts over time. Rust corrodes both the metal and the wood around it, weakening the joint. A wooden dowel, on the other hand, became one with the structure. It was a living nail that grew stronger from the very moisture that destroyed iron. It was the ideal technology for a humid and harsh climate. The joints did not just hold, they became stronger with every rain, with every year. It was a victory of wood over the elements with the help of wood itself. What if I told you that every Viking carpenter spoke a secret language that we are still trying to decipher? This language consisted not of words, but of shapes. It was the language of carpentry joints, which allowed them to erect their gigantic structures without a single metal bracket. The basis of this language was the tenon and mortise joint. This is a classic technique that the Vikings perfected. A protrusion, or tenon, was carved into the end of one log. A perfectly sized socket, or mortise, was hollowed out in another log. This seemingly simple connection was incredibly effective. It prevented the logs from shifting in any direction. The entire load from the weight of the structure was transferred not through nails, but through the wood itself. This made the joint incredibly strong. They used dozens of variations of this joint. There was a through tenon that passed through the groove and was secured with a wedge. There was a hidden tenon that was not visible from the outside. Each joint had its own purpose. Another important word in their language was notch. When two logs had to intersect, for example, at a corner, a notch was made in each of them exactly half the thickness. When the logs were stacked, they fit into each other, forming a smooth, solid plane.
Look how tight that fits. Not a single gap.
Aye, stronger than any shield wall.
This hall will stand for centuries.
This method, known as a bowl joint or claw joint, was the basis of corner joints. It prevented the walls from spreading under the pressure of the roof. This required precise calculation and masterful axe skills. They never relied on just one type of joint. In a complex joint, such as when attaching a rafter to a supporting beam, they could combine a bowl joint, a tongue and groove joint, and secure it all with a wooden dowel. It was a multi-level safety system. The axe in the hands of a Viking craftsman was not just a cutting tool, it was a sculpting tool. They could carve these complex shapes with millimeter precision. Every notch, every groove was made with a deep understanding of how the wood would behave under load. This language of joints was the result of thousands of years of experience. It was passed down from master to apprentice. Knowing which tenon to use for a beam and which notch for a corner was worth its weight in gold. They did not just create joints, they created locks out of wood. These locks locked the structure into a single, monolithic organism capable of withstanding anything. How difficult do you think it was to carve a perfect hidden tenon and mortise joint using only an axe and a chisel? But a sturdy skeleton does not protect against the icy wind. In the next chapter, we will see how they wrapped their houses in a living blanket. No matter how sturdy it was, a wooden frame could not protect against the piercing winds and frosts of the North Atlantic. Simple plank walls would freeze through. The Vikings needed something more, and they found it right under their feet. The solution was turf. In places like Iceland and Greenland, where wood was scarce, turf became the main building material. Viking houses there were not so much wooden as earthen. The wooden frame we mentioned served only as internal support. The walls around it were built from blocks of turf. These blocks were cut from the top layer of soil along with grass and roots.
Set it steady on the logs.
Another block, quickly. The wind is rising.
Sod was an ideal insulator. Walls made of it were incredibly thick, often more than a meter. Such a mass had enormous thermal inertia. It prevented the house from cooling down quickly in winter and overheating in the short summer. It was a living blanket. The grass roots in the sod blocks continued to intertwine with each other inside the wall. Over time, the wall only became stronger, turning into a dense, monolithic mass. The blocks were laid not randomly, but according to a special technology. Herringbone masonry was often used. This made the wall more resistant to settling and gave it a distinctive and beautiful appearance.
And so Leif and his crew sailed further west than any man had dared before, seeking new lands across the icy sea.
Such a wall was completely windproof. No draft could penetrate through a meter-thick layer of earth. Inside the long house, it was dark and smoky, but it was always warm, even when a snowstorm raged outside. Houses built using this technology literally blended into the landscape. From the outside, they looked like green hills covered with grass. It was not just a dwelling, but a part of nature itself. Sod also had good fire-resistant properties. Unlike dry wood, a thick earthen wall could not catch fire from an accidental spark from the hearth. This was an important safety factor in a house with an open fire. Maintaining such a house required constant attention. The turf settled over time and had to be renewed. But the Vikings were willing to pay this price for the warmth and safety that this unique living blanket provided them. The roof was the most vulnerable part of the house. It had to withstand the weight of snow, resist the wind, and most importantly, not leak. The Vikings had no roofing felt, no tiles, and no metal. But they had something that worked even better. They created a multi-layered system that is still used in traditional Scandinavian architecture today. This system was ingenious in its simplicity. The first and most important layer was birch bark. Birch bark is one of the most amazing natural materials. It contains tar, which makes it completely waterproof. In addition, birch bark does not rot in the ground. It can lie for hundreds of years and remain elastic. Craftsmen removed the bark in large sheets. Then they laid it on the wooden roof decking. It was laid like tiles. The lower layer was covered by the upper layer so that water could not get inside under any circumstances. Birch bark was light, but it had one drawback. Strong winds could blow it away. Therefore, it had to be held down with something. To do this, the Vikings used the same material as for the walls, turf. 2 layers of turf were laid on top of the birch bark layer. The first layer was laid with the grass facing down so that it adhered tightly to the birch bark. The second layer was laid with the grass facing up so that a green carpet could grow on the roof. This mass of earth and grass weighed several tons. It pressed the birch bark firmly against the roof, giving the wind no chance. No hurricane could tear off such a covering. In addition, the turf served as an excellent insulator. It retained the heat coming from the house and prevented the roof from freezing. The grass growing on the roof further bound the clods of earth with its roots. This green roof had another advantage. It made the house almost invisible from a distance. A long house covered with grass looked just like part of the landscape, a natural hill. Thus, the Viking roof solved 3 problems at once. The birch bark provided 100% waterproofing, the turf provided thermal insulation, and the overall weight of the structure provided unmatched storm resistance.
And so the Great Bear roamed through the snow, searching for the warmth of the cave.
We have looked at individual elements, the foundation, walls, and roof. But the true genius of Viking architecture did not lie in these elements individually. It lay in how they worked together, obeying a single philosophy. This philosophy was the complete opposite of the modern one. The modern house fights against the elements. It is built on the principles of rigidity. It must be immovable, like a rock. When the pressure becomes too strong, it breaks. The Viking house did not fight the elements. It lived with them. It was built on the principle of flexibility. It was not a rock, but a tree that bends in the wind but does not break. Every element was designed for movement. Post and beam walls allowed the boards to breathe and shift, absorbing gusts of wind. It was like shock absorption. Wooden dowels swelled and became part of the wood, but retained microscopic elasticity. They were not brittle like rusting metal. They allowed the entire structure to play under load. The structural frame itself, especially in ship-type houses, often had slightly curved shapes. The famous curved roof ridge was not just a decoration. Like a ship's keel, it distributed the load and stress more effectively along the entire length of the building. The meter-thick layer of turf on the walls and roof acted as a giant damper. It absorbed vibrations from the wind. It prevented the structure from resonating and collapsing. It was a single living organism. Each part of it was movable but connected to all the others. The Viking house was designed to yield to force, dissipate it, and withstand what would break any rigid structure. They understood a fundamental law of nature. What does not bend breaks. Their houses were built according to this law. They did not try to defeat the storm. They built so that the storm could not defeat them.
Blizzard howls fiercely outside.
Aye, but the longhouse stands strong. We are safe by the fire.
This approach required a deep, intuitive understanding of the material. Viking carpenters did not simply chop wood. They engaged in a dialogue with it, knowing how it would live and move decades after it was cut down. This was their main secret. Not strength, but wisdom. In the ability to create a living, breathing, and flexible structure from dead wood. Upon entering the longhouse, one entered another world. It was a world of dim light, warmth, and smoke. The center of this world was the Langeld, a long hearth that stretched across the entire central hall.
Wind howls fiercely tonight.
Aye, but we are safe and warm by the fire.
This fire was the heart of the house. It provided light in a world without windows. It provided warmth that fought against the eternal cold. Food for the entire clan was prepared on it. People gathered around it on long winter evenings to tell sagas.
The serpent of the world rose from the depths, its scales darker than the longest winter night.
But there was a downside to an open fire: smoke. There was no proper chimney in the roof. At best, there was a simple hole in the ridge or gables through which the smoke was supposed to escape. Most of the time, smoke filled the entire space under the roof. The air was heavy and acrid. This may seem terrible to us, but for the Vikings, smoke was not only a problem but also a solution. The smoke rose and enveloped the rafters and the entire internal structure of the roof. The tar and soot it contained settled on the wood. This process was similar to smoking. Over time, the wood under the roof became as hard as stone. It was impregnated with preservatives. The smoke killed woodworm larvae and fungus. It protected the roof from rot and pests. Thus, the process of heating the house was also a process of preserving it. The smoke, which made it difficult to breathe, also gave the house a long life. This was another example of their ingenious, holistic system. Life in such a house was communal. There was almost no personal space. Along the walls were wooden benches that served as seats during the day and beds at night. Life unfolded in full view of everyone. The constant smoke and dim light created a special atmosphere. It was a closed, warm but harsh world, protected from the chaos of the elements outside.
Warms the bones better than any fur.
Aye, keep the wolves in the cold outside tonight.
The warmth of the hearth, the strength of the walls, the flexibility of the joints, all worked together. A Viking house was not just a building. It was a machine for survival, created with incredible skill and a deep understanding of nature. We can see that the Viking house was an engineering marvel. It was born in harsh conditions where survival was a daily struggle. Every detail of this construction was a response to a specific challenge: rot, cold, or hurricane-force winds. They created architecture that did not rely on modern materials, but surpassed them in durability and sustainability. They used stone foundations to combat rot. They applied flexible ship walls. They invented the living wooden nail, which grew stronger with moisture. They wrapped their houses in a meter-thick blanket of turf. It was a holistic system where each element supported the other. It was architecture that did not fight nature, but became part of it. This is the lost genius of the Viking craftsmen. They built houses that could breathe, move, and live. What other secrets of ancient technologies would you like to unravel? Perhaps you are interested in how the Celts built their fortresses, or how the Incas worked stone. Suggest topics for future videos in the comments, and don't forget to subscribe to our channel.